The problem is Wheatstone network diagram is depicted and the details are mentioned. The diagram has 4 resistors and galvanometer. Their resistances are mentioned and the voltage source, the voltage is mentioned. The direction of the current also indicated. If this is the direction of the current from the voltage source I, where it divides into I1 and I2, and further here divides into this plus this. Therefore, this current equals I1 minus Ig, this current is Ig. And these two combine to give I2 plus Ig through this conductor. And you have to calculate the problem, you have to calculate what is the value of Ig, the current passing through the galvanometer. That is the problem. The diagram they have only given and the details are mentioned. You have to calculate what is the value of Ig using this diagram. In this diagram, we have 3 loops, loop 1, 2, 3. Let us apply the Kirchhoff's voltage law for all these 3 loops. The law for the loop is A, B, D, A. So it is a potential change. There are 3 conductors. This is the conductor and the conductor. Their resistances are mentioned and the currents are mentioned here as I1, I2 and Ig. The potential change is IR. So IR at this conductor, IR at this conductor, IR at this conductor. So what is IR? I is I1, R is 10. That is the IR, potential change. And potential change at this conductor is I is Ig and resistance is 10. Rg stands for resistance of the galvanometer. And potential at this conductor is I2, 5. And the summation involves the sign change. The sign change for this is minus and for this is minus because the direction of the loop current is this clockwise. It is in the same direction. So this will take minus, this will take minus and this will take positive plus because the direction is opposite to this loop current. The summation equals 0, that is voltage second law. And simplify this equation is divisible by 5. Divide throughout by 5, you get this equation and take it as minus and to plus. The equation is 1. This equation is a function of I1, Ig, I2. It is from the loop 1. Let us see what is the second law for the loop 2. So this is the direction of the current, loop current. And apply the same. There are 3 conductors, 1, 2, 3. That is, this conductor, the current is I1 minus Ig into 20 IR. IR means VR. V equals IR. That is a potential change. And what is IR of this? I2 plus Ig into 15. And this IR, Ig into 10 resistance. And the sign convention, this is the direction of the loop current, it is in the same direction. It will take minus, first one will take minus. And these two are in the opposite direction to the loop current. It will get plus summation equals 0. The equation is divisible by 5 again. Divide throughout by 5 and remove the brackets. Remove the brackets. Simplify. You get this value. That is minus 4i1 plus 9ig plus 3i2 equals 0 as equation 2 from this loop. And finally apply, that is the second law to the loop. The loop is A, B, C, E, A. In this loop we have 3 conductors. Conductor this 1, 2 and 3. Potential change is again now, it is that the loop current direction is this. So it is IR means I2 5 and the current is I2 plus Ig into 15. And whatever the potential change at this, it is same as voltage what is mentioned 10. The sign convention is direction of the loop current. These two together same direction, minus minus, and if that is the direction it will take plus 10. So summation equals 0 and this equation again divisible by 5. Divide by 5, remove the brackets, we get Ig value and I2 value. This is, and this is minus 2 friends. And I1 value is not there, so you can write it as 0 into I1 because these equations are functions of I1, Ig, I2. I1, Ig, I2. So it should be a function of I1, Ig, I2. I1 is 0. We have 3 equations. So from the diagram we have get 3 equations. So these equations, look at these equations. You have to solve these equations to get the value of Ig. So what is the method of solving these equations? These equations are similar to these equations. These equations are called as algebraic equations, linear algebraic equations. Linear algebraic equations of 3 variables. Here x, y, z are variables. In algebraic equations we have different types. Linear algebraic equations of 1 variable, only one equation. And linear algebraic equations of 2 variables, 2 equations. Linear algebraic equations of 3 variables, 3 equations. This is of this type. And also linear algebraic equations of 4 variables, 4 equations, like that. So these are algebraic equations. We can solve these. Solving means finding the value of x, y, z using this set of equations. Using the law is known as Cramer's rule. What is Cramer's rule? It is a mathematical rule in matrices and determinants. A mathematical rule in matrices and determinants using for solving this type of algebraic equations. What is the method of solving? The method of solving is this. These are the coefficients of the algebraic equations. Here a1, a2, a3 is the coefficient of x. These are coefficients of y. These are coefficients of z. And these are constants. We can take these coefficients as elements of a matrix. That is in the same fashion. Elements of matrix. That is coefficients of x, coefficients of y, coefficients of z as elements of matrix. It is a square matrix. Same number of rows, same number of columns. and find the determinant of the matrix. Determinant means write this symbol for this. This stands for determinant. What is the determinant value of this matrix? We find the value by this using Cramer's rule. So determinant value of this determinant equals this number into, inside the brackets we have this into this, product of these two minus product of these two. That means when you take this element, we have what is that? That is, leave these elements, that is elements of this row, elements of this column. So remaining is your product of these two. And next term is, when you take this term, leave the elements of this row, leave the elements of the same column, remaining as this one. Cross multiply this into, inside the bracket, product of these two minus product of these two. The next term is, when you take this element, so leave these elements, same row, same column, and remaining here product of these two minus product of these two. We have three terms and sum them with alternate positive and negative. First term is positive, next term is negative, next term is positive, like this. And simplify this, we get a numerical value. That is one numerical value. It is determinant of this matrix. Here after this, if you want to find the value of y, take the matrix, same matrix like this, only replacing these elements, that is column of these elements, column of these y elements by the constants. So retaining the same, replace this column to find the value of y, replace the column by the column of these constants. Find the determinant for this matrix in the similar way. First term, second term, third term. We get a value of what is that determinant. It is delta y. So that is a numerical value, Take the ratio, that is delta y by delta, you get a value. That value is the value of y. Numerical value. This is how we can find the value of y. In the similar way, we can find the value of x and z. To find the value of x, what happens? Same matrix, replace this column of elements by the constants like this. Find the determinant, take the ratio to get the value of x. To find the value of z, same matrix, replace this column by this constant, find the determinant and take the ratio, this that value divided by this value equals value of z you get. That is the Cramer's rule, mathematical rule to find or to solve these linear equations. So same method is applicable for this because these are similar to algebraic equations of variables I1, Ig, I2. So let us write them in the matrix form. Here I1, three equations, 1, 2, 3. I1 is 2, minus 4, 0. 2, minus 4, 0. Ig values, that is 2, 9, 3, minus 3. And I2 values, minus 1, 3 and minus 4. So this is the matrix form of these algebraic equations. Find the determinant. Determinant is in the same fashion. This into bracket, product of these two, that is minus 36 minus of this. Minus of minus means plus 9 again. Second term minus 2, minus of these two into product of these two minus product of these two. 16 minus 8. And the third term is plus minus 1 into plus term, minus into plus is minus 1 into product of these two, 12 minus product of these two, 0. So remove the brackets and simplify. This becomes 54, this becomes 32, this becomes 12, totally we have minus 98. So minus 98 is the numerical value. It is a determinant of this matrix. In this expression, we are asked only to calculate what is the value of Ig. So for that, you take, so we have to take the matrix of what is that Ig here, these elements as replace these elements by the constants. What are the constants in the equation here? After equals 0, 0 minus 2. So replacing the central column Ig, this column of elements by 0, 0 minus 2, it becomes a matrix for this. Find the determinant, that is delta Ig is 2 into, that is the same fashion, this means minus of 0 into anything is 0, not written, plus minus 1 into this minus 1. Simplify 12 minus 8 equals 4. So delta Ig equals 4. So value of Ig, that is like this, delta Ig by delta, that is 4 divided by minus 4 divided by minus 98 equals minus 2 by 49. So value is minus 2 by 49 amperes. That is the current, amount of current flowing through is 2 by 49 amperes. So this is the process or mathematical process for the evaluation of Ig. So this is all the process of mathematics for finding the value of Ig. This is the problem. And the second problem is this. The diagram is not given. The problem, I read the problem. There are two cells which are connected in parallel to external resistance. The value is mentioned. There are two cells which are connected in parallel to external resistance. This is 5 ohm. How do you write the pictorial way, that is diagram for that? 2, that is parallel connection. This is the, if you look at these are in parallel connection. It is connected like this in parallel phase. That is the correct way of representing. Like writing the diagram is most important by looking at the problem, what is the data. So these two cells are connected in parallel to this resistance. This diagram we need to draw. And here you are given some data. You are not given the voltage source of these cells directly. Instead, it is given EMF of this and internal resistance. EMF, internal resistance. And this is the details and resistance of the external circuit. And you have to calculate the current in each branch. That means what is the value of I1, value of I2 and value of I1 plus I2. This is the current in this branch, current in this branch, the current in this branch. That is the problem. So with this diagram, we have to apply again Kirchhoff's voltage law. For there are two loops. This is loop 1, loop 2. Apply Kirchhoff's voltage law for this loop. So this is the direction of the current, loop, clockwise direction, loop current direction. So when you see that loop, for this loop, what is the Kirchhoff voltage law? That is voltage source of this is V as taken as V1, not given. And the potential change at this, the current is here, look here, from this the current it is flowing here in the direction is I1, and the current from this source is flowing like this in the I2. Both of them will combine here, join and come out as I1 plus I2 through this conductor. So in this loop you have two conductors, this conductor and this conductor, and it is V1 and IR is current is I1 plus I2, R is 5. Potential change. Sign convention for this is plus, this is minus. Get this. But V1 value is not given directly, instead we are given this value. But using this equation, we know the equation for the voltage source from the cell. It is E minus IR. Recall the equation, the standard equation. V equals E minus IR. We can take this as V1. This becomes E1, I1, R1 for this cell. Given the value of E1, given the value of R1, 1.5, that is R1 is 1 minus I. So V1 is this. Put this into, substitute for this V1. Put this equation 2 into 1, we get this. And simplify. Remove the brackets, simplify, we get this equation. 6I1 plus 5I2 equals 1.5, equation number 3. We get this equation from this loop. Let us see what is the equation from this loop. So this is again what is the clockwise direction, loop current direction, you can take as clockwise direction. Apply Kirchhoff's voltage law, potential change plus potential change. Potential change is, I can take this as V2, and potential change is IR. What is I? I1 plus I2 into R. This will take plus, this will take minus. Direction take like this. And V2 is not known. Calculate V2 from these details. That is this one. And this value, substitute the values. R2 is 2. V2 is 2. It becomes 2. This is V2. Put this into this equation. 5 into 4. We get this equation. And simplify, we get this equation. This is equation 6. So this is the equation, we get it from this loop. From these two equations, there are two variables, I1 and I2. We have to solve for I1 and I2 using the same method, Cramer's rule. Here, square bracket with only two variables. Equation of only two variables. So it must have only two rows and columns like this. From these equations, so to write these equations as matrix. So elements of I is 6 and 5. 6 and 5. Elements of I2 5 and 7. These are the. Find the determinant. Determinant is easy now. This is product of this minus product of this. 70. Delta, that is determinant of this matrix is 70. To find the value of I1, write the matrix, that is same matrix, replacing this column by the constants. What are the constants? 1.5, 2. 1.5, 2. Find the determinant. Determinant is product of this minus product of this. That is minus is 0.5. So 0.5 is the determinant of this. It is delta I1. Let us call it as delta I1. To find the value of I2, find the determinant of what is delta I2. The matrix, the same matrix, replace this column by constants. It is same constants. Find the determinant. It is delta I2. product that is product of this minus product of these two. This one and minus is 4.5. That is delta I2. This is delta 1. You get the value of I1. If you take the ratio, delta I1 by delta R, delta is 17. 0.5 divided by 17. 17 is this. That is the value, numerical value. Is the current, sorry, that is the value, numerical value, is the current value of I1 in this branch, current flowing here. To find out I2, divide this value by 7, delta I2 by delta. You get this value, it is the current in amperes flowing in this branch. I1, I2. What is the value of I1 plus I2? It is high. Sum these two, you get this value. This plus this is this. That is the current value in amperes in this branch. This is how we can calculate the value of I1, value of I2 and value of I as I1 plus I2. This is the mathematical procedure for that kind of calculation. Think that you have to draw the diagram, that is a suitable diagram for the given data of the problem. Then only you can solve the problem at the ease. With this you have completed the session. Let us continue with the next class.